What's AI evals?
Evals are a systematic way for you to look at the data your AI produces so that you can stop guessing, so you can move beyond vibe checks. If you're building a product, you want that product to be good. Probably the most important part is this error analysis part. Error analysis is
How many evals should we write?
it's not about how many evals you should write. You should keep looking at data until you feel like you're not learning anything new.
You talked about LLM as a judge. What does it mean? How would that function?
The main question people have about LLM as a judge: how can you just ask an LLM to judge itself? And so the answer is,
Hey folks, welcome to another podcast episode of Product Founder. Today we have an expert on AI Evals, Hamel Husain. Super excited to have you on the podcast.
happy to be here.
Awesome. When I was going through my school years and also university, I was one of the folks that always asked questions which everyone had in their mind, but never really asked. So I think it was 3 months ago. I think Lenny had the CPU of ChatGPT on his podcast. And then at the end of it, he talked about AI Evals, which it was the first time that I heard about it. Then what I thought about it was, I thought it's something that you use only for LLMs, like to build the LLMs. Then I started a little bit research about it. And also for this podcast episode, I asked many people, do you know what is it? Because I was preparing for the episode. And everyone just had something vague understanding. What does it do? So today, I want to really talk about it. So I'm asking you, what are the evals?
Yeah, evals are a systematic way for you to look at the data your AI produces so that you can stop guessing. So you can move beyond, let's say, vibe checks, and you can ship with confidence that some confidence of where you understand how your system is performing and your AI is performing. And it's not only about knowing, it's also about improving. So evals is the only way after a certain point that you can improve your system. So if you're stuck, like for example, if you're stuck in terms of, hey, like I don't really know how to make my AI better. I don't really even know where it's broken, but I don't know how to make it better. Evals is the key tool for you to lean on to help you go through that process.
Okay, when you now say making your AI better, so from what we see in the industry, a lot of people are using like ChatGPT wrappers, prompt engineering. Is that something you're referring to, or you're talking about someone like building something like an LLM themselves? Let's pause here for a second. The other day, I was looking into our channel analytics and I noticed many of you guys are watching a lot of our episodes, but not yet subscribed to our YouTube page or Spotify. I will ask you as a favor, please support us by subscribing to our YouTube page and Spotify page, and I will promise you I will do everything in my power to make each episode better and better. Thank you.
It's really referring to AI products. So when we're talking about evals, there's two classes of evals. There's evals for foundation models, like how smart is a model generally. And, you'll see a lot of benchmarks like MMLU score, human eval, so on and so forth. That's different. That's a kind of eval. That's general purpose eval. That is very unrelated to your product eval. So if you have some kind of customer service support chatbot or a legal assistant or a real estate assistant or whatever it is, if you're building a product, you want that product to be good. You don't want it to be just a naive wrapper that you haven't iterated on and tried to fit to your users. So that's what, when we're talking about AI evals, at least in this conversation, that's what we're talking about is product evals.
Okay, and just trying to imagine a little bit more. Is it like writing tests, right?
Kind of. So it's not a little bit different than writing tests in the sense that in traditional software, you think about what you want to happen beforehand, and you write a test to make sure that thing that you specified beforehand does happen. And you also might respond to errors. If you find that you have an error you didn't think of, you might write a test for that as you find it. When it comes to evals, it's primarily driven from a bottoms-up approach. At least product evals, you should be looking at lots of data and annotating that data to figure out what exactly about your AI is not working the way you like. And so a lot of people think they know what the AI wants to do, but the research shows that it's really hard to provide complete specifications up front about what you want your AI to do. And it's only after you look at lots of data that you can refine those specifications and figure out what exactly it is that you want. One key part of evals is a process called error analysis. And error analysis is a structured way of looking at data, so you're not lost. Because if I tell you look at data, you're going to say, well, what data? And how much data? And all of these questions come up. And error analysis is the technique that we teach. And it's fairly simple. It's approachable to anybody. You don't have to be a technical person. Basically, what you need to do is there's the first part of that process is called open coding, where you go through traces or logs of your LLM and you annotate any failures that are happening. You stop at the most upstream failure you see, and you take detailed notes about why something is not ideal or something is broken. And you keep doing that for a representative number of traces, and then you categorize those notes into failure modes. And then you can have very sophisticated approaches to analyzing that data, but you can even count that and say, okay, what are the errors that are happening the most? And then now you have a way to prioritize what evals to write. Not only what evals to write, but what to do and what to focus on, where to spend your time when you're engineering your AI product. So that's the key part of evals. That's probably the most important part, is this error analysis part. Now you might be wondering, what happens if you don't have any data? What data are you talking about? I just sat down today and started building my app. That's fine. So number one, when you are just starting to build an application, you don't necessarily need evals right away. You need to have a product first. And vibe checks are totally fine in the beginning because evals have a little bit of a cost. However, after you kind of have this prototype, then what you can do is you can start generating synthetic data if you'd like. That's one approach. Another approach is obviously get some users, and that's preferred. And really, it's most likely that you want to use both approaches. So you get some users, see what's failing, and you generate synthetic data based upon what you see is failing. And so, yeah, we can go into a lot of details on that. And you can get more sophisticated, but you can start with very simple approaches and get very far.
You mentioned a couple of things. One is vibe checks. What is vibe checks?
Vibe checks is just use the application, get a feeling for what it looks like. So for example, vibe checks is just emotional based evaluation, which is not completely useless. It is useful, right? You rely on vibes for many things in life. You judge people all the time with vibes. You judge AI with vibes. Does it feel right? Is it doing the right thing? Maybe you can't explain it. The tone is wrong. And so the vibe checks just mean, hey, you're not putting a scientific process on it. You're just using the application and does it feel right? And that's totally fine. That's great when you're building sort of a prototype. As your application gets more and more complex and you're trying to do more and more things, it's really hard to rely on vibes because you don't know if you fix one problem, are you causing other problems? If you change your prompt to address something you don't like, is it inadvertently causing another issue that you fixed before that's unrelated? Things like that. And it becomes unwieldy really fast. And so there's a quote by Greg Brockman, the co-founder of OpenAI, also lead engineer at OpenAI, that evals are all you need. And it's a joke, but it's true because once you have really good evals, it's very clear what you should do next. And it's very clear on how to improve your system.
Let's say we want to build a chatbot. You mentioned, okay, some time has passed and then we want to basically improve our systems. How many evals should we write? Yeah.
So it's not about how many evals you should write. It's more about, there's no set number of a number of evals you should write. You should write enough evals to cover your failure modes, to have enough test coverage. But really what you should be stressed out about is not the number of evals you have. It's are you looking at enough data? So how much data you look at, the simplest heuristic to understand is you should keep looking at data until you feel like you're not learning anything new. And the technical term for that is called theoretical saturation. But it doesn't really matter what the term is. It's almost easy just to forget about that term and say, look, I'm going to keep looking at data until I'm not learning anything new. And I hammer on this point because a lot of people, they don't look at their data. You're building an AI app and your large language model is emitting a trace of some kind, which is a detailed log of the back and forth that has happened with the LLM, including the system prompt, any tool calls that are made, any user messages, AI messages, internal thoughts, so on and so forth. All of these traces are really rich information about the way your system is working. And so you should really be looking at that. And if you're looking at that carefully and you're looking at enough data, you won't ever ask how many evals you should write. You will just understand like, okay, I need to write an eval for this problem that I saw. So all evals you write should be in response to a real problem. It should not be like, I'm going to go write an eval about helpfulness today, because we don't even know what that means. And then second, that might not be a problem that you have. And there's infinite evals you can write, and because of that, your evals need to be grounded in real problems, not hypothetical problems.
Can you give an example with the chatbot, what kind of evals we can write? What would be the input data and what's the output going to look like, both if the eval fails and also if it succeeds?
One kind of easy to understand example is you are an apartment leasing assistant and you are helping customers who want to rent an apartment schedule a tour. And your chatbot is, so a customer can ask a question like, hey, can you schedule something for the beginning of next month to come look at your property? And the AI will respond with some times, right? Now, if you're this apartment leasing assistant, if you're building this apartment leasing assistant and you're looking at the data, you're looking at your traces, you might find, for example, that the times that the AI is proposing to your customer don't make any sense. Like the date is wrong for some reason all the time. And you're like, that's weird. Why is it getting the date wrong? Okay, you don't worry about that yet. You write notes like there's a date problem. And it turns out so that's the open coding part. You figure out after categorizing those errors, you're like, oh, wow, I have a lot of these date problems. Okay, now you have a reason to write an eval because it's a real problem and it's a big problem. It's a big enough problem. So then what you might do is say, okay, how do I develop some test data for this? And so what you can do is either search your real traces for where people are asking for data, for people are asking to do schedules, and use those as test examples, and then annotate some ground truth. So like, hey, what is the actual date that should be given? Or like, are these date options provided? Are they correct? Yes or no? And you can do that with code. Because if it's deterministic, you might not need an LLM. But let's say for whatever reason you need an LLM, that's fine too. So, you would build some kind of tests with this test set of dates. And you can get an LLM to help you. Let's say you don't have traces of like people asking for dates, or you want to stress test it even more. So you can like have, and I'm talking about a real example. So, in this case, I worked with this company, had this exact same problem with the dates. We said, okay, we got an LLM to expand the problem and say, okay, like, what are other tricky ways that you can ask for dates that might confuse the system? So, leap years or whatever, right? We wanted to make sure. And then there was all this like logic. So you can go with like LLM as a judge or code-based evals. So they're referred to as reference-based evals. So if it's a reference-based eval, you already know what the answer is. In that case, it's more likely you don't need an LLM to do the eval. You can write code that will just test if the output is what you want. And then there's reference-free evals, which you may need an LLM as a judge because it's not one right answer. It's more subjective. And you need some intelligence of some kind to like judge that. So you end up writing either one of those two. An LLM as a judge is its own deep rabbit hole. So one question is, how do you write a good LLM as a judge? We can get into that later. But to go back to this like calendar example, it sounds fun, like, okay, we've had this data example. We collected a data set with a bunch of different challenges for an LLM, and then we had an eval that said, okay, like, is this right or not? Is the output right or not? And then we just kept iterating on it until we were a lot more confident that the AI was doing what we wanted. But there were some dumb things that were not in the prompt in that situation. Like the date was not properly in the prompt in all situations. So like the LLM had no way to know what the right date should be. Pretty obvious. But it's like not something that you would be able to figure out if you weren't looking at the data. And we found all kinds of other problems. Like people, not only was the date wrong sometimes, but we found that people are often asking to reschedule an appointment, which is natural, right? You make an appointment, you want to reschedule it, and the AI would say, okay, no problem, but they would just schedule a brand new appointment. They wouldn't cancel the old one. But like you won't know that unless you don't look at the data. You're like, wait, we don't have a rescheduling tool. We just have a scheduling tool. So you're like, oh, this is a problem. And there's about 10 other problems that we found like that just by looking at the data. So like looking at the data is extremely important. Like there's no shortcut around it. But yeah, that's like an example of like, okay, how you find the problem to write an eval. Then there's like, yeah, the code-based eval and an LLM-based eval, which we can talk about, but I'll just leave it there so I don't ramble too much.
No. It's just great. This is exactly what I want to have on the podcast, is these real world examples. Everyone also, including me, we can kind of imagine it more how it will function. You talked about LLM as a judge. Can you a little bit more elaborate? What does it mean? How would that function?
Yeah, LLM as a judge means you ask another LLM to see if your LLM's output is right or not. So if you wanted a meme for the podcast and this part, like a cutscene, it would be like that one with Obama putting the medal on himself. That's like LLM as a judge. It's like you're asking an LLM to do that. And the reason like the meme comes to mind is it actually surfaces the main question people have about LLM as a judge. Like how can you just ask an LLM to judge itself? Or why is it okay to ask another LLM to judge this LLM? Is that really, like, how do I know that it's doing the right thing? Like, I don't know what that LLM, is that LLM as a judge is it doing a good job or not? Like, there's another eval, right? And so the answer is yes, it is another eval. And what you need to do is you need to label some examples as a human being first. Before you do LLM as a judge, you need to actually... So first of all, your LLM as a judges should be binary outputs, yes or no. Should not be like Likert scales of 1 to 5 or something like that. There's reasons why. It's mainly because it's too complicated to do the Likert scales in most cases, and people get really confused. And so you have a LLM as a judge producing a score. Usually we recommend binary score, like I just mentioned, but you want human labels, or you want expertly annotated labels to say, okay, for this failure mode, what is the ground truth? And you want to measure how good your judge is against that ground truth to have some confidence to say, hey, the judge is okay enough. Like, I can trust the judge. And that part is really important. If you don't do that, and most people are not doing that, then what happens very quickly is that people lose all trust in your evals. And the moment people lose trust in your evals, they lose trust in you, and then they also lose trust in what you're building. Because now, there's no way for them to sort of verify that, or there's no way for them to trust you in the product that you're building, especially if you lead with, hey, here's some numbers that, purport to be a good proxy for how good the system is. And if it turns out that's not the case because you're not doing evals correctly, then you actually can cause lots of problems for yourself.
When we write an eval and then a new model comes out, does it help to just immediately just jump in and then test the new model against our pipeline or the prompt that we have written, or it doesn't really help?
Yeah, it's totally fine to test new models. You should be trying new models. Your evals, workflow, and pipeline should be fairly modular so that you can try new models against those evals. You might need to change the prompt a little bit for a new model. It depends. You shouldn't be having to change the prompt too much if you're within the same family of models. Like if you're still using OpenAI and you're kind of going from one frontier model to the next, you shouldn't have to be, changing it too much. But in general, like your evals should be fairly modular so that you can apply it across any LLM.
Yeah, because why I'm asking is that I'm just thinking, okay, so we spent some time building, let's say 10 great evals, and then now we're more confident about our pipeline and a new model comes out. Obviously, you cannot just switch and then let them the product to work on production, right? So you want to test it again. So maybe if you had the 10 pipelines previously built, you can just evaluate the new model with your current system faster.
Yeah, if you have evals, all this stuff becomes easy because the decision criteria becomes easy. Are your evals improving or not? If yes, okay, switch.
Okay, awesome. And why do you think that PMs should be good at evals?
So the most important thing about evals is, again, looking at data. And it's looking at data and responding to data and noting what is wrong and what is off. Like, hey, this AI is not really helping the customer. Or, you know what, the AI is doing X, but it should be doing Y instead. Or, you know what, this thing is missing from the experience. This is not what people want. It seems, the AI is kind of doing the right thing superficially, but this is not really helping the customer. So who's the best person to make those judgments? Turns out a lot of times is a product manager. So also, like, what is a prompt? A prompt is, in many cases, a detailed specification of what you want your product to do. It's a kind of a distillation of, in some sense, like user requirements, but also how you want the experience to be for your user. And so, again, many times the right person to articulate that is a product manager. And it's not the case that you have to, in traditional software, you have a product manager that maybe writes a Google Doc that tries to articulate all these things and then has to convince many engineers to make sure that their vision has been implemented faithfully. So with the case with LLMs, like, you're communicating in plain English, right? And so there's not so much reason for disintermediation between the PM and the AI. And so because you can prompt, also the product manager should have direct access to the prompt and have good tools for them to iterate on the prompt and do tests. And so it turns out like the labeling, looking at data, iterating on prompts, even iterating on the LLM as a judge prompt, because the LLM judge has a prompt as well. And again, the LLM as a judge prompt is also an articulation of user requirements, so on and so forth. And so all that stuff, is better if a product manager can directly specify that instead of playing game of phone and having the message be diluted or whatnot. And so what we advocate for is bringing the domain expert into the process. So domain expert is a lot of times the product manager. It's not always the product manager, but you would hope there's a very high intersection between the domain expert and the product manager.
And you talked about tools to check if the prompt is a good prompt. What are the tools that we could use as a product managers?
Yeah. So this is one situation where it's useful if your engineering teams can expose tools for you as a product manager. For example, like if you have an application of some kind, let's say a chatbot, and let's say again, like a real estate assistant, can you have an admin view that allows super users to change the prompt and see what the difference is? Those things go a long way because it allows someone like a product manager to like kind of play with the prompt and do some experiments and see the output in the same way the user would. It's not a perfect solution. So you want to play with prompts and you also want to write evals, or you want to run evals against your new prompt, which, you can do. So there's eval tools out there as well. So there's things like, there's too many to name, honestly. Some popular ones are things like Braintrust, Arise, Langsmith, and these are some popular ones out there. And, they all have prompt management, like utilities, and allow you to run evals against your prompt as well. So there's different approaches for it, and they all have trade-offs. But essentially, what you want to do is make sure that your domain experts are involved in the prompt crafting itself and also involved in the data labeling process and looking at lots of data.
Okay. And what is your suggested roadmap to learn AI evals?
One good way is to take the course. So, we have a course on evals where we walk you through a very detailed process about how to go through this step by step. Starting with error analysis, then moving on to the different kinds of evals, and then also architecture-specific concerns like what to do with RAG, what to do with agents, so on and so forth. So we walk you through all of that with lots of examples. So it's really about practice. Yeah, so I would say the roadmap is something that looks like the course, I would say. There isn't great public material out there. That's something we are working on as well. It might take some time to do that, but we started it with the course. There's also blog posts that are publicly available. I've been writing about evals for about 2 years now. You can definitely start with the blog posts that I have about evals.
Did you start it with evals before the ChatGPT explosion or after that?
I've been working in machine learning for over 25 years now. And in machine learning, what is machine? So machine learning before ChatGPT and stuff like that, it's similar in a lot of ways. It's stochastic outputs. So even like a forecast, if you're trying to forecast sales, right? It's very classic machine learning. You have stochastic outputs. Like there's an error in the output. Or even if you're classifying dogs and cats or bicycles or doing anything, right? Like classic machine learning, there's errors in the outputs. So when you have a system that has errors in the outputs, what do? How do you test a system that is stochastic, is non-deterministic? Well, it turns out like a lot of those techniques can apply to generative AI as well, and can apply to these generative AI products, like analyzing them and figuring out how to improve them and where they're breaking. You go through the same exact process. So it's not really evals is like a separate thing. It's more extremely ingrained into the process of building any AI. You can sort of ignore it in the beginning, but you need to do some kind of evals one way or the other. Like, there's no escape.
I just checked your LinkedIn and I noticed that you also worked at GitHub. So I'm curious if you worked on Microsoft Copilot or anything similar to that.
Yeah. And so I did a lot of research at GitHub on large language models. I led research around semantic understanding of code, and we published some benchmarks and some papers and some models. Those benchmarks were actually used by OpenAI to iterate on Codex, which is a very old model that I think is like deprecated now, which is for code understanding. I didn't directly work on Copilot. I would say like the work I did was like a precursor to that work. But, I had left GitHub when that work began to do my own things.
Awesome. You mentioned OpenAI, so I want to bring this question up. How is OpenAI approaching evals, and how can we learn from that?
So OpenAI is primarily concerned with foundation model benchmarks, as I mentioned at the beginning of the podcast, which is completely different than your product evals. So OpenAI is generally not concerned with your product's evals. And they probably shouldn't be because it's very specific to you. So there's not too much to learn from OpenAI, let's say, because that's not a problem that they are focused on. They're trying to make sure their model is as good as possible generally. They do have some tools for you to try to do your product specific evals, but they're very nascent and it's not a focus area of theirs as of now.
Okay. I think somewhere I saw like a PDF book. I think it's written by you and Sharia. And there was something called Three Gulf of LLM Pipeline Development. So I want to ask you, what are those?
Yeah. So in our course, we have a 150-page book and we keep adding to it. We're kind of incubating a book that one day we will publish with our detailed thoughts on evals and how to do them and so on and so forth. And, mental models are always helpful. Because, it always comes up like, what is the process? What is the roadmap? What is the step-by-step? 1, 2, 3. How do I know what to do next? And so this three gulfs model is a mental framework that you can use to organize some thoughts around evals. So if you can categorize the problems that you have with LLMs. Actually, let's bring it up on the screen. So this is a three gulfs model of challenges in LLM pipeline development from our book. And the book is like, quite comprehensive. Like this is a table of contents that we have in the class. Gives you a little bit of a preview. You can download this, by the way. You can download the table of contents in the first chapter from our course page for free if you want to take a look. But, we talk about what is evaluation, some evaluation basics. We talk about error analysis. We talk about how to collaborate with the team on evaluation, how to implement automated evaluators, including LM as a judge. How do you evaluate multi-turn conversations? How do you evaluate RAG? How do you tackle specific architectures? Things like agents, tool calls, multi-step pipelines, dealing with CI/CD, how to build interfaces for error analysis and evals, and then how to improve your system based on evals. So these are like, it's quite a lot of things to talk about. We start off the book with this mental model, this three gulfs model. And this three gulf model basically helps you organize like what kinds of problems you might be facing. So gulf of comprehension is basically, do you understand what your problems are? Like, do you even understand where your failures are to begin with? So is your failure, so it's like, basically, do you have lots of unknown unknowns? Or do you not comprehend what it is that your AI system is doing? The only way you can really do that is to look at data. Then there's something called gulf of specification, which is here. And basically what you want to, gulf of specification is, have you told the LLM everything that you want it to do? Like, is your prompt correctly specified? Is it, is it specific enough? Are you instructing the LLM on everything you want to do? And then there's this gulf of generalization, which is like, okay, now that you have told the LLM everything you want to do, like you understand what you want to do, and you've told the LLM what you want it to do. If you've done those two things, can the LLM generalize? Meaning, is it actually carrying out what you want? And so you can have a failure in any of these three parts. And it's kind of a cycle. And so there's islands here. So these are three gulfs and there's islands. And basically, you need to cross these gulfs in order to get to these islands. You have to keep going between them. And the islands are the developer, the AI engineer developer. Then there's the LLM pipeline. That's where you put all your specifications in and try to see if your model can generalize. And then there's data. And data is where you look at lots of data to see if you can cross that gulf of comprehension. You have to keep going through this process over and over again. So it's just a mental model. And basically what we talk about in the class is like, okay, if you encounter an error, what island are you on, or what gulf do you need to cross? If it's a generalization problem, that's very, very different than a specification problem. Because specification problem is, okay, maybe we need to work on your prompt. Comprehension problem is like, we're not looking at enough data. Generalization problem is probably the more challenging one. And, you have to like optimize your system, maybe with fine tuning, maybe with better models or optimizing RAG or something like that. But, it's a mental model, how to organize your thoughts, essentially.
Where people usually do the mistake, like which one do they get it wrong more?
They get it wrong by not looking at data. That's where everyone goes wrong.
Do you have any advice on that?
Just start. Start by looking at some examples of what your AI is doing. Start looking at data. Log that data and start looking at it. Challenge yourself to look at least 100 examples. And I will guarantee you that you will find it to be useful. And you will become an immediate convert to the idea that you should look at data. And you will tell all your friends that are working on AI that they need to be looking at their data too. That's how powerful it is. So just start by just force yourself to look at 100.
Awesome. Hamel, thank you so much for joining this podcast episode. I think this is a great point to end this episode. Is there anything else you would like to share with the listeners? I know the next cohort of the courses are coming up soon.
Yeah, please join us in our next cohort. We would love to have you as a student to teach you about evals. It's quite comprehensive. We have lots of guest speakers from the industry. We have a handful of vendors who are going to be doing deep dives as well as far as tools are concerned. However, tools are not the primary focus of the class. We teach you agnostic ways to master evals regardless of the tools that you're using. But yeah, that's pretty much it.
Awesome. Thank you so much for joining again.
Thank you.
Wow, you made it till the end. I'm very proud of you. Comment down below which part of the podcast did you like the most and who should I interview next. Also, on the screen, you will see a lot of our other great episodes that you should definitely check out.